So in this video, we are going to learn how to determine the interval where a function is either increasing or decreasing, its relative extrema, the concavity, and the point of inflection of a function. So let's start off with this example. So given that f of x is equal to x to the power 4 minus 6x cubed, we are going to find a, the intervals where f is increasing and decreasing, b, its relative extrema, c, the intervals where the function is concave up and when it is concave down, and then d, the inflection points of the function. So we are given the function f of x to be equal to x to the power 4 plus, we have minus, so minus 6x to the power 3, and then a, we want to find the interval where the function is increasing and decreasing. So how do we solve this? Now the first thing we are going to do is to find the first derivative of this function. So that is given by f prime of x, and that is equal to, we are going to have 4x cubed minus 18x squared. Now we can simplify this as we are going to factor out 2x squared, and then we have inside of the bracket we are going to have 2x minus 9. So this is f prime of x, the first derivative of this function. Next, we are going to set f prime of x to 0. So we set f prime of x to 0 so that we have 2x squared times 2x minus 9 equals 0. So we have the factors to be, we have 2x squared equals 0, we divide through by 2, we have x squared, and that is equal to 0, and for that matter we have x equals 0. Again, we have 2x minus 9 equals 0. We transpose negative 9 to the right hand side, we divide through by 2, and then we have x equals 9 over 2. So we have x equals 0, x equals 9 over 2, and these are the critical points. Now the next thing we are going to do is to draw a number line, and then we represent x equals 0 and then x equals 9 over 2 on the number line. So we have this to be 0, and then we have this to be 9 over 2, which is the same as 4.5. Now to determine the interval or the intervals where the function is increasing or decreasing, we are going to substitute in values, or a value that is first of all less than 0, next a value that is in between 0 and then 9 over 2, and then the third one will be a value that is greater than 9 over 2. So first of all, let's start with a value that is less than 0. So we pick x equals -1, and then we substitute that into f prime of x. So we have f prime of -1, f prime of -1 to be 2 times -1 square times 2 times -1 minus 9. So we have -1 squared, that is 1, 2 times 1 is 2, 2 times -1 is -2, minus 9 is -11. So we have 2 times -11, and that is -22. So we have a negative value here, and then we pick a value that is in between 0 and then 9 over 2. So we can pick x equals 1. So we have 2 times 1 square times 2 times 1 minus 9. 1 squared is 1, 2 times 1 is 2, 2 times 1 is 2, minus 9 is -7. So that gives -14. So we also have a negative value here, and then lastly we have f prime of, let's pick a value, say 5. Let's pick 5. X equals 5. and that is greater than 9 over 2. So that is equal to 2 times 5 square, and then big bracket, we have 2 times 5 minus 9. 5 squared is 25, times 2 is 50. 2 times 5 is 10. 10 minus 9 is 1. And so we have 50. And then 50 is a positive value. Now, wherever you see a negative for f prime of x in any region, it basically means that the function is decreasing in that interval. And then when you see a positive f prime of x, then it means that the function is increasing in that interval. So what this primarily means is that the function decreases from negative infinity through to 0, and further decreases from 0 through to 9 over 2. And then the function increases from 9 over 2 through to positive infinity. So therefore we say that f increases, that is from 9 over 2 through to positive infinity, and then f decreases from negative infinity through to 0 union, and it further decreases from 0 through to 9 over 2. Now, since we have a single point or a single value 0, which is separating the two decreasing intervals, we can basically ignore 0 and say that the function decreases from negative infinity through to 9 over 2. So any of the two is correct. Now let's move on to B. So for B, we want to find the relative extrema. So basically we want to determine if this function has either a relative maximum or a relative minimum point. Now let's consider this same diagram. So this is the diagram of f prime of x. Let's again consider this diagram. So we have 0, we have 9 over 2. This is negative, plus. Now you realize that the function decreases from the left of 0. The function decreases from the left of 0 and then further decreases to the right of 0. Now, since the sign of f prime of x on both sides of 0 remains the same, it means that 0 is not a relative minimum, neither is it a relative maximum, because the sign of f prime of x on both sides of 0 remains the same. Now let's move on to the point x equals 9 over 2. You realize that the sign of f prime of x is negative on the left side of 9 over 2 and then becomes positive on the right side of 9 over 2. So from the left of 9 over 2, we see the function decreasing and then increases on the right of 9 over 2. Now, since the function decreases on the left and then increases on the right, it means that we have a relative minimum point, or better still, a relative minimum at x equals 9 over 2. So when the function decreases from the left of x and then increases on the right of x, then we have a relative minimum at x equals that value. And then when the function increases on the left side of x and then decreases on the right side of x, then we have a relative maximum at x equals that particular value. Whereas in a situation, the sign of f prime of x does not change on both sides of a value, then we say that the function has no relative minimum, neither does it have a relative maximum at x equals that value. So looking at this graph, you realize that the function decreases from negative infinity through to 0, and then further decreases from 0 through to 9/2. Now, since f prime of x does not change sign on both sides of 0, then we say that the function does not have a relative minimum, neither does it have a relative maximum at x equals 0. So we can conclude that this function has a relative minimum at x equals 9/2, and then it has no relative maximum. Now let's move on to see where we are going to find the intervals where f is concave up and when f is concave down. So to find the intervals where the function is concave up and concave down, we need to find the second derivative of this function. Now we have the first derivative of this function to be 4x cubed minus 18x squared. So we have f prime of x. We have f prime of x to be 4x cubed minus 18x squared. So let's further differentiate this function, and that's going to give us the second derivative of f of x. So we have 12x squared minus 36x. So we can simplify this as we factor out 12x, and then inside of the brackets we are going to have x minus 3. So that is f prime prime of x. Now let's set f prime prime of x to 0 and then solve for the values of x. So we say that we have 12x into bracket x minus 3, and that is equal to 0. So we have 12x equals 0. We divide through by 12, and then we have x equals 0. Again, we have x minus 3 equals 0, and then x is equal to 3. So therefore we have x equals 0, x equals 3. So we are going to represent the two values of x on the number line like we did for the graph of f prime of x. So this time we have f prime prime of x. So we have this to be x equals 0 and then x equals 3. The next thing we are going to do is to plug in a value that is less than 0, a value that is greater than 0 but less than 3, and then a value that is greater than 3. So for a value that is less than 0, we can choose x equals -1. So we have f prime prime of -1, and that is equal to, using this function, we have 12 times -1 times -1 minus 3. So we have 12 times -1 is -12, and then -1 minus 3 is -4. -12 times -4 is 48, and that is a positive value. Next, we choose a value that is in between 0 and 3. So let's choose x equals 1. So we have 12 times 1 times 1 minus 3. 12 times 1 is 12. 1 minus 3 is -2. 12 times -2, we have -24. So we have a negative value here. And then f prime prime of, let's choose a value, say 4, which is greater than 3. So we have 12 times 4 into bracket 4 minus 3. 12 times 4 is 48, and then 4 minus 3 is 1. So we have equal to 48, and that is also a positive value. Now, a function is said to be concave up if f prime prime of x is greater than 0. That is, if f prime prime of x is a positive value. Now you realize that we have a positive value here, or we had a positive value here, that is in this interval, and then we also had a positive value here, also in this interval. So what this primarily means is that the function is concave up from negative infinity through to 0, and then also from 3 through to positive infinity. And then for concave down, f prime prime of x should be less than 0. From this interval, you realize that the function is concave down, that is, we have a negative value. So the function is concave down over the interval 0, 3. So within this interval, f prime prime of x is less than 0. So the function is concave up within the interval negative infinity 0 union 3 plus infinity, and then concave down within the interval 0, 3. Now let's move on to D, where we want to find the points of inflection of this function. Now the point of inflection is basically the point where the concavity of the function changes. That is, either it changes from concave up to concave down, or better still, it changes from concave down to concave up. Now you can as well say that the point of inflection is basically the point where the sign of f prime prime of x changes either from positive to negative or from negative to positive. Now if you choose x equals 0, you realize that the sign of f prime prime of x changes from positive to negative, that is positive on the left side of 0, and then it changes to negative on the right side of 0. Again, when you choose x equals 3, you realize that the sign of f prime prime of x changes from negative on the left side of 3 to positive on the right side of 3. Therefore, we say that x equals 0 and then x equals 3 are the points of inflection of this function. Now, if you want to actually obtain the point of inflection of a function, then basically you want to consider the ordered pair of the x value and its corresponding y value. So for x equals 0, we want to find its corresponding y value. So we are going to substitute that into the function f of x. So we are going to have f of 0, and that is equal to, we had the function, the original function was f of x equals x to the power 4 minus 6x cubed. So we are going to have 0 to the power 4 minus 6 times 0 cube, and that is equal to 0. And then for x equals 3, we have f of 3 equals 3 to the power 4 minus 6 times 3 to the power 3. Now 3 to the power 4 is 81. 3 to the power 3 is 27 times 6 is 162. 81 minus 162 is negative 81. Therefore, we say that the points of inflection of the function f are, we have 0, 0, and 3, negative 81. Notice that if the concavity does not change on both sides of a particular x value, or better still, if f prime prime of x does not change in sign on both sides of an x value, then it means that that particular x value cannot be a point of inflection. So that's it for today's video. Thanks for watching and see you in my next video. Bye bye.